Here is a matching type question on general organic chemistry. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us now begin solving this step by step. Determine P is equal to number of anti-aromatic compounds among the 6 shown. Anti-aromaticity requires A. Cyclic, B. Planar, C. Fully conjugated, continuous p orbital overlap, and D. 4 n pi electrons, n is equal to integer, n is equal to 1. 1. Cyclobutadiene, cyclic, planar, fully conjugated, 4 pi electrons, 4 n is equal to 1. Anti-aromatic. 2. Pyridazine, 1, 2-diazine 6-membered ring with 2n atoms and alternating double bonds, 6 pi electrons, aromatic like pyridine. Not anti-aromatic. 3. Toluene, methylbenzene benzene ring, 6 pi electrons, aromatic. Not anti-aromatic. 4. Cyclobutadiene dianion or cyclobutene. If this is the plain cyclobutane square with no double bonds, it is not conjugated and not anti-aromatic. Non-aromatic. 5. Oxacyclobutadiene, oxet with double bond 4-membered ring with O and a double bond, 4 pi electrons, planar, cyclic, conjugated. Anti-aromatic. 6. 2-cyclopentane, cyclopent 2n 1-1 membered ring. The carbonyl contributes to conjugation. Considering the pi system, it has 4 pi electrons in the ring. C is equal to C and C is equal to O contribute to +2 equals 4 pi electrons in a cyclic conjugated system. Anti-aromatic. Thus P is equal to 3. Compounds 1, 5, and 6 are anti-aromatic. Moving on to the next step. Determine Q is equal to total number of resonance structures of CO3, 2. Carbonate ion has one central carbon double bonded to one oxygen and single bonded to 2 O- groups. By rotating the double bond among the 3 oxygens, we get 3 resonance structures. Q is equal to 3. Moving on to the next step. Determine R is equal to number of alpha hydrogens in the given carbocation. The carbocation is cyclohexane ring with C+, CH3, 2 attached at C1 of cyclohexane. Alpha carbons are carbons directly adjacent to the positively charged carbon, C+. The C+ is bonded to CH3 groups and C1 of cyclohexane. Alpha carbons to C+. 2 methyl carbons, each CH3 has 3 H2 times 3 equals 6 alpha H from the methyl groups. C1 of cyclohexane is directly bonded to C+ and also to C2 and C6 of the ring. Weight, C1 of cyclohexane is the carbon attached to C+. The alpha carbons to C+ are the 2 CH3 carbons and the C1 of cyclohexane. C1 of cyclohexane has how many H? C1 is attached to C+, C2 and C6 of the ring, so C1 has 1 H, tertiary position, since it's bonded to C+, C2 C6 and 1 H. So alpha H is equal to 3, from CH3, plus 3, from other CH3, plus 1, from C1 of cyclohexane, is equal to 7. R is equal to 7. And for the final step, determine S is equal to total number of geometrical isomers of CH3, CH is equal to CH, CH is equal to CH2. This is penta 1,3 diene, CH3, CH is equal to CH, CH is equal to CH2. The double bonds are at C2, C3 and C3, C4, or C1 is equal to C2 and C3 is equal to C4 in different numbering. For CH3, CH is equal to CH, CH is equal to CH2. The C2 is equal to C3 double bond, substituents on C2 are CH3 and H, substituents on C3 are CH is equal to CH2 and H, both carbons have two different groups, so this double bond can show EZ isomerism. The C3 is equal to C4 double bond. If we consider CH is equal to CH to C4 has H and H is equal to CH2 terminal, so no EZ isomerism here. So only one double bond gives geometric isomerism, two isomers, CIS trans or EZ. S is equal to 2. Determine T is equal to number of compounds more acidic than CH3CH2 ethanol, pKa-16, from the given list. 1. Phenol, pKa-10 more acidic than ethanol. Yes. 2. 4. Nitrophenol, pKa-7.1 more acidic than ethanol. Yes. 3. CH3CO, acetic acid, pKa-4.75 more acidic than ethanol. Yes. 4. CH3SO3H, methane sulfonic acid, pKa-1.9 more acidic than ethanol. Yes. All four compounds are more acidic than ethanol. T is equal to 4. Calculate the final answer. P+Q+R+S+T, 15 is equal to 3 plus 3 plus 7 plus 2 plus 4, 15 is equal to 19 minus 15 equals 4. Therefore, the correct answer is P3, Q3, R7, S2, T4, formula P+Q+R+S+T, 15, final 4. Therefore, the correct matching is P matches 3, Q matches 3, R matches 7, S matches 2, T matches 4, final matches 4, formula matches P+Q+R+S+T, 15.